So, ladies and gentlemen, in addition to the classic UV lamp technology, the LED technology is already established, right? It's conquering more into more areas of UV curing. Why? Well, because it's robust, it's more powerful and more efficient. It's easy as that. And for comparison, 2011, the efficiency was about 25%, and today, almost 50%. And the trend is still rising, but more slowly. So it's worth asking, what different LED systems are there actually? What are they used for? And most importantly, which is the ideal system for your application? Let's find the answers together with Holly Steedman, the Business Development Manager for Integration Technology. Hello, very warm welcome. And Thilo Kirsten, the Head of Mechanical Design, Sheetfed at IST Maths. Hello. Hello. So, first of all, before we are doing the deep dive, perhaps you can introduce yourself. What is your job at IST Maths at Integration Technology?
So at Integration Technology, I'm responsible for business development, and this basically, simply put, is creating long-term growth in the company through partnerships or strategic planning, and also through knowing the market and the customer's needs also.
Mm-hmm.
I'm the head of design department at IST, and our task is to find the perfect or optimal technical solution based on customer requirements or customer processes.
Mm-hmm. So, your point of view, what makes a particularly good LED system?
Well, an LED system must be robust for the environment. That goes for any kind of system where it's going into industrial situation. So for me, that's a key point. It has to be also easy to integrate with other processes in the printing machine, for example. So this is a very important points for me.
And other important aspect is the UV system have to be designed exactly of the point of the customer requirements. We will see later on that there are different solutions for LED systems, and our we are responsible for to find out the right system for that.
Perfect.
Sorry.
It's not our native language. What shall we say, right?
Yeah, I have the advantage today.
Yes, exactly. But we're doing our best. So, Holly, Integration Technology is not based in Germany. You already told us you have a huge advantage today because you're based near Oxford in the UK. So can you describe the company a bit better?
I'd love to describe the company, but even better, we have a small film today which discusses about the products and about integration technology.
Wow,
so
okay,
let's take a look. Yeah.
Yes, let's have a look.
Hello and welcome to Integration Technology. I'm Simon Roberts and I'm Managing Director for Integration Technology and IST UK. We were founded in 2000 and were early pioneers of UV curing technology. We have sales and technical offices all across Europe, North America and the Far East, and we became part of the IST METS group in 2015. We're pioneering, innovative and flexible, and we base our business around 3 key areas of product supply. Our global customers come back to us time and time again for our high-performing, high-reliable standard range of products. We also can tailor those standard products to specific individual customer requirements. And finally, we offer a full bespoke design service for complex print and industrial projects.
My name is Andre Nicholson and I work as a research and development engineer for Integration Technology. Integration Technology has been a pioneer in UV technology since its inception, where it developed a UV system to suit the needs of new wide format printing machines. We have been developing UV technology since 2002 and currently hold some of the earliest patents in this area. Our products are some of the most powerful available, not just from the development of higher power LEDs, but also from techniques to maintain the LED junction temperatures, which is critical to achieving a long service life. Integration technology systems are running some of the highest output powers available today in the market. But this is not achieved by just increasing the power through the diodes. This comes from enhancing the optical components within the system. We are always looking ahead, and we currently have a program looking into UVC LEDs, their efficacy, uses and applications.
Hello, my name is David Johnson and I am the Sales Director here at Integration Technology. I'd like to talk to you today about some of our products and the core technology that goes into making the devices work and work well. Let's start with air-cooled. Most of our products that we actually supply are air-cooled, and most of our customers come to us and ask for an air-cooled product in the belief that they are simpler and easier to use and put into their systems. All of our air-cooled products are fitted with Watercooled technology. Watercooled allows us to control the speed of the fans by sensing the temperature of the UV LED diodes, and by doing so we're able to increase the life of the diode, reduce the noise of the fans and increase the output as well because we have a better control of the system. In this air-cooled product, you can see that we have a number of drive cards driving a number of modules. In this case, 360mm of modules and 4 drive cards. On the other side, as it's air-cooled, we have the fans that actually do the cooling mounted above some copper heat sinks which remove the heat from the LED modules. Water-cooled systems are usually smaller in footprint and lower in weight than the correspondingly sized air-cooled units. Furthermore, water-cooled systems have no air movement, and this makes them very good for use in very special environments such as clean rooms and glove boxes. Each of the water-cooled systems comes with steady cool. This is a technology that maintains the temperature of the LED's diodes very precisely, and this in turn gives you a very good process control. For every 1 degree Celsius temperature rise, the UV LED drops 0.5% of UV output. Therefore, 5 degrees would be the equivalent of a 2.5% drop in output of UV from the system. Therefore, a water-cooled system that maintains the diode temperature really is good process control. Steady cool also allows us to run the water temperature slightly higher, and this means that we can reduce the risk of condensation in high humidity environments. As water is a better medium for heat removal, it means we can run the water-cooled units at a higher power than we can the air-cooled units. So with the use of the steady cool technology, that means we can get to 30 watts per centimetre squared. This makes our water-cooled units one of the highest power systems available on the market today. As you can see, this water-cooled version of an LED system also has drive cards, the same as the air-cooled system, and water-cooled modules at the bottom. In this case, the manifold pumps the water in here and removes it from here, instead of having air-cooled heat sinks which are cooled by fans. Interestingly, the cost to build a water-cooled and an air-cooled unit are almost the same. When you think about it, that's quite logical. They have the same components. They all have LED modules, they have heat sinks, and they have a way of removing the heat. The main difference in cost is the chiller that's required for a water-cooled system. However, this can sometimes be negated by using a chilled house water supply. All of the systems, both air and water-cooled, are fully addressable, meaning we can adjust the length or the pattern of the array according to the substrate or print that's being put down. We also produce some handheld area cure systems, typically around 110mm square, which could be used for the repair of surfaces and components in the field away from a base station. All of our high-power UV LED systems utilise the XT8 UV LED booster technology. XT8 reflects the very latest in chip packaging technology, and combined with phase change material offers an exceptionally high level of efficiency from the UV LEDs. XT8 technology is the result of Integration Technology's continued research into pioneering and innovative UV curing techniques.
Hello, my name is Andres Sanchez. I'm controls engineer at Integration Technology. We take quality control very seriously. which is demonstrated by the fact that we are comfortable offering 5 years warranty in our XT8 modules. To support this, we have an ISO 9001 certificate in which our processes require us to test and record 100% in everything we ship. The test facility is equipped to functionality test all our equipment at full power and over an extended shock period. Each UV LED head or power supply has test certificate where inputs and outputs are measured. This means that we have auditable data for everything we ship.
At Integration Technology, our mission is to collaborate with our customers to provide flexible, optimised UV LED curing solutions for all printing and industrial applications. And we strive to move to a greener and more environmentally friendly LED future. Thank you for joining us today, and I hope you've enjoyed learning more about Integration Technology, and enjoy the rest of the IST UV days on air.
Hello and welcome, and thanks for joining today. Today I want to discuss with you how you choose the correct LED system for your application. Seems simple, but there are some things that you need to take care of and consider. So, what is the main point to start with? What do you have to think about? Well, of course, you want to cure your product. You want to cure your ink, you want to cure your adhesive. It needs to be cured. That's the main point here. But it doesn't just need to be cured, it needs to be fully cured. And this is where intensity and dose comes into play. So I'm going to describe a little bit the differences between the two and how this affects your application and your choice of lamp system. Intensity, also known as peak irradiance, or you could commonly think of as power of the system, is described in watts per centimeter squared. For example, you're here often 20 watts per centimeter squared system. But important there with the intensity is that it's really dependent on the distance between the lamp and the substrate. This comes into play also. And also then, so we have dose. Dose can be also then described as the amount of UV that is at that point on the substrate. And there it is dependent also on the speed normally of the system, of course, that makes sense, intensity versus speed. And also the emissions window of the lamp. This also has an effect, obviously, because of the size of this. So there's the basics about them. So how does this apply to the application? Here you can see a very basic, simplified diagram that explains these both in the reality of a system. You have this example, you have 10 watts per centimeter squared, and you have 2 seconds of UV time, of the time of the UV on the substrate. So if you calculate that, then in this case we have 20 joules per centimeter cubed. That's just a simple example just to explain how they're related to each other. In the reality, obviously, how does this affect our choice? So you can see here in this example, we have an ink that requires an intensity of 16 watts per centimeter squared, to get the reaction going. However, we also need a dose of 400 millijoules per centimeter squared to actually complete the curing process. So we got two figures there. Now, if we just take the intensity, it looks pretty simple. If you look at our choices of the overviews of our systems there, okay, we just take the VZ system with 16 watts. But we have to also consider the speed of the system, and we mustn't forget that. And we see here how that makes a difference. If we just consider a speed of 25 meters per minute, then it looks, you can see from the measurements of the dose, it's enough to cure the ink completely. However, if we look at the 50 meters per minute, we do not have enough dose there to cure. And there we could then have problems if we selected a VZ system. So we need to take a different system, for example, the SCX. So you really have to remember to consider both the intensity and the dose requirements of the product you are trying to cure. It's not just dose and intensity that you also have to consider. You also have to consider the substrate you're printing on. The color, for example, or the transparency has an effect on how ink or coating is cured on the surface. As we discussed, also speed is directly related to dose. So you have to be sure that you have the maximum running requirements and that your lamp will also be able to manage with these speeds. Complex shapes should not be forgotten. In many industrial applications, you're not printing on a flat area or flat substrate. You have to consider also where you might have shadows created by the parts. You may need two lamps at different angles, for example. So these are other things that you need to consider in your application. As I said, the distance is very important here. With LED systems in our area, the optimal distance is 5 millimeters. After 5 millimeters, then you dramatically reduce the intensity that reaches the surface. So that needs to be implemented in the machine. You need to have that correct distance to enable the lamp to be optimized and to run correctly. And also, last but not least, the chemistry, the formulation. You mustn't forget that side of things. The chemistry has to match the lamp, the wavelength. The photoinitiators need to be the correct photoinitiators for the LED system, or the wavelength that you're using. So that should also be considered. Also, consider different colors, for example. If you're in digital printing, then CMYK, they cure differently. Pigments absorb or reflect light differently. So this should always be tested, not just test one color tone. All colors should be tested also. Okay, so we spoke about our end curing. What about, do I need something else in my system? Do I need pinning? What is actually pinning for those who are new to this concept? Well, pinning, I always think of it like making the ink into a jelly stage. So we don't want to cure the ink completely. We want to set it in its half jelly wobbly stage. And the reason we do that is so that we can print on top, or we can maintain the correct dot gain to have an outcome of a good print quality. A perfect example of that is single pass printing with white and CMYK. There you need, if you're printing on a black substrate, for example, you need to print white first. And there then you need to pin the ink to enable the CMYK to be printed optimally on top to prevent any issues with the print quality further down the line. It can also be used to pin the CMYK to prevent further dot gain, depending on the system of the setup. So it really is a very interesting LED topic as well. Here you can see, for example, if you're pinning with too much energy, too much intensity, the white will be too overcured, and then the colors will not wet on the surface. The CMYK will not wet correctly, and you have a poor print quality. And it goes also in the opposite direction. Not enough energy, and then the CMYK will be washed out of effect into the white again. So not creating a good print quality. So you have to find that pinning sweet spot. And this can be, in some industrial projects, a long process, but you get there in the end. It just takes a little bit of time. So we have our pinning, we have our end curing, but it doesn't just stop there. There's other options. Water-cooled and air-cooled systems. Which one should I choose? Is one better than the other? Well, in short, no. We need all types of systems, water-cooled and air-cooled. They have their advantages and disadvantages. We heard also in the video about air-cooled and water-cooled systems. So they both have their place. For example, one big advantage of Water-cooled system is there's no air movement. This is needed in some applications. On the other side, with water cooling, there's less, and also there's less sound and less noise from the water-cooled system. But then, also with the air-cooled systems, you can have an advantage of easier integration. You know, you only have to worry about the LED head. You don't have to worry about integrating any tubes or any chiller into your system. This could be an issue for some. So they both have their place, and it really is back to what is correct for the application. But there are some myths around there about air-cooled and water-cooled systems. Water-cooled systems are often known to be very expensive. However, this is not the case usually. This is often just the case of the additional cost of the chiller. Air-cooled systems, for example, have often, it's often been said that they have too many maintenance, too many moving parts. The reality is you need to have maintenance on any type of system. Maintenance is key to stop any breakdowns or any issues with the systems. The same goes for the cooling tubes on the water systems. Also, with maintenance, then you avoid any issues with the cooling tubes. Also, another point with the water-cooled systems, condensation is often mentioned as an issue. And as you heard in the video also, we can reduce this by reducing the temperature of the cooling system. So there's ways around these small differences in the systems that we handle through our technology, but also the main point is both have their advantages and disadvantages. So what about integration? What can go wrong when you're integrating your system into the lamp into your system? Well, the main thing is, we do see it sometimes, is it's pretty much an afterthought curing. At the end, okay, we have to cure this ink. What now? Okay, we need a lamp. Where are we going to put that? Is something that can come up sometimes. So think of it from the beginning. In single pass applications, also you may need a cure delay. So you need to build this space into the machine to allow for that. So don't leave it as an afterthought. And that's where we come in. We're helping to find the right solution for your application. And this can also be by tests, for example. In very complicated situations or on complex systems, the best way is tests. Nothing beats a real test sometimes. And there we can support through either in lab or on-site with testing and finding the correct system. And also back to our systems, how modular they are and how we are a flexible company and flexible on our product side. Just some small change, for example, on the positioning of a connector, of water cooling or electrical connector, can make a big difference integrating the machine. It can make a real change in the plans for the machine there. So this is something that we're proud to be able to offer our customers. So I want to share with you a few case studies to show you the real advantages in a real life situation. The first one I want to talk about is a little bit about pure LED advantage, where a customer has seen a good advantage with the LED system. Here's an example of a company who are printing a special biodegradable material, and this is flexo printed. And they're also using a special ink for this application because their goal was to reduce the environmental impact as much as possible and to reduce the CO2 footprint. Therefore, they were looking to LED. We've heard a lot about LED being a greener technology, so it made sense for them. Also, they had some issues with heat on the surface of the very thin material. And here we were able to install a system that could give them the advantage of reducing their costs and being more environmentally friendly. They reduced their costs by 50%. This obviously has something to do with how LEDs are only on when they're needed. They're on for a shorter amount of time than the standard UV system. So they could reduce their costs. And also, as a bonus, they managed to also reduce the thickness of their material because of the heat the less heat generated from the LED system. So they had a bonus saving or cost saving that wasn't expected due to the LED system. So really positive case there. And also a case where water-cooled systems can really be an advantage. An application on monochrome display manufacturing of a adhesive. There, they really needed to reduce the heat, and also they wanted to create a greater curing even across the whole system. It was a relatively big system, so they wanted to have the curing exactly perfect across the whole wide range. And also, they also wanted to reduce the air flow in the system, in the environment, due to the application itself. They needed to remove that movement of air because it would interrupt with other part of the manufacturing process. So we were able to do that in that situation, to take out the air movement with a water-cooled system. And they could successfully then go forward with this application. So again, a real advantage there. But what other applications and markets? We've heard a lot about printing, obviously, because this is a core business from us. But we are in other markets as well. And we've already seen other examples of adhesive curing, not just of inks or coatings. But we're also in other markets, like Dave said in the video, we've developed other products, for example, in the smart repair market from the automotive industry, and also could also be in marine industries as well. The application markets are opening up wide for LED systems. More and more products are turning LED, more and more chemistries are also moving to LED. So really, the world is our oyster with LED at the moment. So I want to say thank you for listening, and I hope you learned something, and I hope you enjoy the rest of the day.
So thank you very much, Holly, for giving us these insights